values: the initial position, 300 meters, the acceleration is the gravity, minus 9.81 meters per second to the square, the initial velocity, 100 meters per second, and the point A says to write the position equation for the plastic water bottle. For this we need to use this formula. It's the final position, the initial position, the initial velocity, the time, the gravity, and the time. So we need to substitute. It's 300 meters, the initial position, the 100, the initial velocity, the time, we don't have the time, and the gravity. Then we need to solve. We need to change the values to get the equation.
Okay, we have the letter B, find the equation for the velocity for the plastic water bottle using the derivative definition with limits. So first we investigate to get this function, and we have this of the last equation, the last problem, and then we substitute everything using this with this, and we will sit here the minus 4.9c squared. We substitute 2 squared with this, as they say here, and we put it like this, and then h below them, and the minus is right here, and we keep the x is all the equation, right, as this, and then we have the limit h0. We got for this the square binomial, and with the signs we change them all for the minus, and then we add and splice and rest some values as this one, this one, this one, this one, this one, and this one. So we got this, and then we go here. But what we have to do? Well, we can solve both h's, and then we go here, and we substitute h with 0. So we got here, and this number for 0 times is nothing. So we got the equation for the velocity.
Okay, then the point C is to calculate the acceleration equation for the plastic water bottle. So we're going to use this equations formula that we got. We're going to use the last equation, the velocity equation, and then we're going to substitute here. So we're going to have minus 9.8 times t plus h plus 100, and then the other equation over h. So we can eliminate, we solve, and we can eliminate some values like this, this, and this. We're going to have this, and then we can eliminate the h's. We're going to have the acceleration equation. Calculate the height of the bottle after 2 seconds. The 2 seconds means the time. The time we have to substitute the formula with time. The time means the seconds. SO means the 300 meters. VO, velocity, initial velocity, R is 100 meters per second, and the acceleration is this. So we substitute everything and we solve, and we first get this using this. And then we divide for 2, and it's 19.2, and we add and subtract, and after all that procedure we get the position of the bottle after 2 seconds is 480.4 meters. Well, and finally we have the point F, calculate after what period of time the bottle hits the ground. Well, we have the formula of the first question, and for the time we have to use the general formula. As we can see here, we substitute with all the numbers. This is A, B, and C. We substitute, so we got these because we are solving.
And then we have the 100. We have this. So we go here. We substitute and we solve this again. So we have this formula, but with the plus and minus, we have to do both T1 and T2. And our answer is minus 2.65 seconds. And the second one is 23.06 seconds. So the time can be negative, so this is our answer.